Hey guys, today we will be starting a new unit, Unit 2, which is all about functions. So to start off this new unit, we first have to know how to identify a function. So we're going to look at the top part of the notes, and it says identifying functions given ordered pairs, tables, or math means. So if it's one of these three things, this is what you're looking for. A function is a relation or rule that assigns each input value exactly one output value. Okay, so for every input, there's only one output. That's very important. Every input only has one output. So what that means for us, since we deal with coordinate points, is that each x value is paired with exactly one y value, because x represents our input and y represents our output. That's the official definition right there. Each x value is paired with exactly one y value. This is a little shortcut though, so therefore if a relation has repeating x values, then it is not a function. So if the x's are repeating, it is probably not a function. There's a few exceptions to this rule, but this is generally the case. So let's open up the notes, and we're going to look at examples of ordered pairs, tables, and mappings. Okay, so we're going to start off with ordered pairs. So ordered pairs are just points. So if you remember, it's always x comma y, all the way across these points. So the definition in the front says that for every x, there is only one y. So when x equals 1, y is 2. When x equals 0, y is 4. When x equals -1, y is 6. When x is -2, y is 8. So notice that every x value is different. So this is a function. Okay, so let's look right below. So again, these points are always x, y, x, y, x, y, x, y. So what I would start off by looking at is all of the x values and check to see if they are different. So what I'm noticing on this one is that this first one and the last one both have 3 as their x value. So if there's repeating x's, more than likely it's not a function, but you still have to double check something. So check to see what it's matched up with. So see how the y value is different for each point? So that means that x equals 3 is paired with 2 different y values. The definition of a function said that every x is only going to have one y. So since this one has 2 different y's, that makes this not a function. Okay, so now let's move on to tables. Tables are very similar. It's just kind of set up differently. So the good thing about tables is that it's going to be labeled. All of your x's are on this side, all of your y's are on this side, but they match up horizontally this way. So when I look at this table, I'm going to look at my x's first, and I see that they're all different. So, I mean, there's 2 1s, but one's negative and one's positive, so those are different numbers. So all of them are different. Then I'm going to take a look at my y's, and I see that 6 is there twice. That's actually not a problem. What we're focused on is repeating x's. So the repeating y's, it's kind of something to try to throw you off. It doesn't really make a difference. As long as all the x's are different, which they are, this table up here on the top represents a function. Now let's look at the one at the bottom. So there's first, second, third, and fourth point. All my x's, all the y's. So this one is kind of obvious. When I'm looking at my x's, I notice that the last 2 are both the number 2. They both are the same. So repeating x's is usually your tip off that something's wrong here. But what's more important is that each of them different y values. So same as the pairs before, x equals 2 is paired with two different y values. So definition of a function is every x only has one y. This one has two y's, therefore this one is not a function. Okay, and then last ones up here on the top section are mappings. So these kind of bubble things here. So again, it's labeled x and y. So all of these would be your x's and all of these would be your y's. So it's similar to a table that way, but different in that they don't just match up horizontally, they match up where the arrow goes. So the first point would be negative 2, 3, because that's matching up. Next one would be 0, 7, then 4, 1, and 5, 5. So always go with the arrows. But all of the x's are different, and they're only matched up with one value. That's exactly what we want. So this is a function. Okay, so now let's look at the bottom example. All of the x's are different, 1, 4, 7, 10, so nothing's repeating. All my y's are different, so nothing's repeating there. But take a look at how they're paired. So 1 is paired with 1, 7 is paired with 2, 10 is paired with 5. But this 4 right here is a little off to me because it's paired with negative 3, but it's also paired with 5. It has two arrows coming out of it. So that's what's throwing everything off here. X equals 4 is paired with two different y values. It's paired with negative 3, but then it's also paired with positive 5. Therefore, this is not a function. Okay, so that is ordered pairs, tables, and mappings. So bottom section is going to be reserved for how do you identify a function given a graph. So these are so important that it's a whole section just for graphs. So we use something called the vertical line test. A graph that represents a function will pass the vertical line test. So this means that a vertical line, so vertical means up and down, so like this, can be drawn on the graph, and it's going to pass through at only one point. So kind of the same idea as looking at every x only has one y. So every vertical line will only pass through one point. That's how you would pass. If for some reason the vertical line passes through the graph at more than one point, then it's not a function. So we're going to get lots of practice on graphs. So hopefully this will clear some things up. Okay, so let's take a look at the inside. All of them are graphs, but these first two are just kind of scatter plots. They just have points everywhere. So what we're going to do is draw some vertical lines and make sure that it only ever crosses through at one point. So if I do a vertical line here, so sure enough, it's only crossing at one point. Let's do one here. Only crossing at one point. Only crossing at one point. Only crossing at one. And only crossing at one. Each time it only intersected with one point. So this is a perfect example of a function. Okay, so let's look at the bottom. So we're going to do the exact same thing. Vertical line, only pass through one point. Vertical line, only pass through one point. Vertical line, uh-oh, something bad happened here. It's passing through two different points. So I don't even need to check the rest of it. It already failed the vertical line test. So this is not a function. So it failed the vertical line test at x equals 2. So in other words, x equals 2 has two different y's. Let's say fails. Instead of writing vertical line test, I'm going to put VLT at x equals 2. Okay, so now let's look at some continuous graphs. So right next to it. And we're going to start the exact same way. So I'm going to do vertical lines pretty much all throughout the entire graph. And what you should notice is that every single time it's only passing through one point. So this is a function. That's a lot of highlighting. You don't have to do all those highlights, but this is just a way to check. Okay, then right below it, that circle. So again, I'm going to start with highlighting. So I like to start at the very end, and right there, we're good. It only crossed at one point. Okay, then let's move on. Next one, and this is where our problem already comes in. It crossed at 2 points. So I don't need to check anymore. Already, I could tell you that this is not a function because it fails the vertical line test, fails VLT at, this is x equals -3. As long as you can find one x value where there's two y's, it's already not a function. Okay, and one last example, still some continuous examples, but I wanted to give you some weird shapes that you would normally see. Okay, so I'm going to start doing some vertical lines. First one seems okay. Only crossed at 1 point. Okay, next one still seems okay. Only crossed at 1 point. And I'm going to just keep doing my vertical lines until I see a place where it crosses through more than once. And as far as I can tell, it only ever crosses at 1 point at every single highlight. Yeah, just 1 point. So this is a function. This is kind of an advanced function. You'll see that in Algebra 2. That's trigonometry. Okay, let's look at right below. So I'm going to start at the very left. And if I do this vertical line, I'm okay for now. It only crossed at 1 point. Okay, so then let's do another line. Instead of going in order, I'm going to kind of go to the other side over here. And it fails. There's 2 different points that it crosses through. So this one is not a function because it fails the vertical line test at x equals 4. In fact, it fails the vertical line test at -3, at -2, at -1, at 0. All the rest of these it fails. I just happen to pick that last one. Okay, so that's how you distinguish between what represents a function and what doesn't. Just because it's a table or just because it's a graph doesn't automatically make it a function. The big thing here is that there is only one y for every x. Every input only has one output. Guys, there is an assignment on the Schoology page. Very simple multiple choice, 6 questions. And just let me know if you have any questions.